There we go. Special relativity is based on two ideas. Special relativity is based on two ideas. And the first one is this. And I'm just going to say this, and then we'll understand what it means in a second. So, no matter what constant velocity you have, the laws of physics must always be the same. No matter what constant velocity you have, the laws of physics must always be the same. So what this means basically is that no matter how fast something goes, we want to have one set of rules that always works. We don't want to have one set of rules for how physics works when you're going 100 miles an hour and a different set of rules for how physics works when you're going 200 miles an hour or 300 miles an hour or whatever, okay? So we want one set of rules. And even if people report different results in at different speeds, we need to have a way to explain the differences in those results. Let's just do an example, okay? Let's do an example. Let's say I was on, let me get this out of the way. Let's say I was on a train, okay? Let's say I was on a train. Oh, and check out these graphics. Here we go. Boom. I'm on a train now. Yay. I gotta get used to trains, though, because anytime anybody ever explains relativity, trains are almost always involved in that explanation. So, here we go. Let me just move over a little bit. All right. Okay, so I'm on a train. All right. Now, in this situation, I want you to imagine that you guys are all standing at the station. So this is you guys. All right. Whoa, focus. Okay, there we go. Now, here we go. In every single one of these examples I'm going to give, you guys are going to be sitting still at the station, and I'm always going to be on the train, okay? Now, okay, here we go. I'm going to ask a bunch of repetitive questions right now, so try to throw me some answers as quickly as you can. Don't worry if you get them wrong. We'll make it make sense. So let's say right now, this train is not moving. Okay? This train is not moving. Okay. So from my point of view, if I look down at the train under my feet, I see that this train is going 0 meters a second. Okay? 0. It's going 0 meters a second. From your point of view, if I'm just sitting at the station, how fast is this train going from your point of view? Don't overthink it. It's not moving, so what speed is it? What speed do you guys see it moving? And don't worry about writing meters per second. And remember, the train's just sitting at the station. Yeah, just 0, right? Just 0. No speed. So we would both agree right now that the train is not moving away from me at all, and it's not moving away from you at all. Now, I'm going to start saying point of view in a slightly different way. I'm going to say relative. Because when we say relative, if I say what is the speed of the train relative to me, I mean from my point of view. How fast is it moving away from me? Relative and point of view are kind of the same thing. So the speed relative to me is 0 meters a second, and the speed relative to you guys is also 0 meters a second. Okay, now, let's say I threw a rock off the train. Okay, we're gonna have to do some slight tiny little bit of math here, but don't worry, it's not gonna get too bad. I need a rock. Here we go. When I looked up rock online, this is one of the first pictures that came up, so I thought that was kind of funny. So here we go. I've got a rock. All right. I've got a rock. Let's say I took that rock and I threw it off the front of the train. Oh, where's my rock? Where's my rock? There we go. I took that rock and threw it off the front of the train at 20 meters a second. Ugh. Bunk. There we go. So I took it and I threw it at 20 meters a second. I'll write that down up here. And don't worry about actually writing units when I ask you this in a second. Just give me a number here. How fast did that rock go from my point of view relative to my body? If I threw it at 20 meters a second, I'm going to see it go 20 meters a second. So relative to me, I saw that rock go 20 meters a second. Now, relative to you guys, how fast did you guys see the rock go? Don't overthink this. How fast did you guys see the rock go relative to you? Just give me a number. We'll assume it's all in meters a second. $20 also, because I'm standing on a train that is not moving. Basically, I'm just standing in front of you guys, right? And so if I threw it at 20 meters a second, we would both see the same thing, right? We would both see the same thing. So we'd both see 20 meters a second. Now, here we go. The next thing we need to ask is this, is if I threw it at 20 meters a second, after 1 second, let's say it lands after 1 second, how far forward would it go? Well, if it was going 20 meters a second, in 1 second, how many meters will it go? Don't overthink that. If it was going 20 meters a second, how many meters did it go in 1 second? 20, okay? So basically, I would see this rock land 20 meters in front of the train, and you guys would look up and see basically the same thing I saw. 20 meters in front of the train, it's going to land. Okay, now, here we go. Let me get my rock back up here with me. Now let's say different situation. Different situation. You guys are still sitting at the station, but this time, the train is moving. Whoa. Here, these are motion lines, okay? This is like anime motion lines coming out the back of the train because it's, I'm moving real fast that way. Okay? And by the way, here we go. By the way, the train itself is moving 50 meters per second. Okay? That's how fast I'm driving. Ignore the rock for a second. Okay, so here we go. From your point of view, relative to your bodies, how fast is this train going by? Don't overthink it. How fast is this train going past your bodies? So relative to you, how many meters a second? 50. 50, right? This train, you're going to see moving past you at 50 meters a second. But here's where we got to be very careful. When I look down at the train, I'm on it, right? I'm on this train. So if I look down at the train, do I see the train go 50 meters a second away from me? Yes or no? Do I see this train go 50 meters a second away from me? No. Right? No. I don't see the train move away from my body at all. So relative to me, what speed is the train going? Relative to my body, what speed is the train going? 0. I know that the train is actually moving because I can see the world go by at 50 meters a second backwards. But from my point of view, the train itself is not going any meters a second away from me. So we could say, relative to you guys at the station, the train is going 50 meters a second. But relative to me, it's 0. Okay. And somebody asked, should you be drawing this? I can't really answer that question because for different people, some people might benefit from drawing all of this, some people might not. But you'll always have this video, so that should work. Okay, now, here we go. Let's say I grab my rock and I throw it exactly the same as how I threw it the first time. So I take my arm and I just throw it exactly the same as what I threw it the last time. So what I'm gonna see is I'm gonna see this rock go 20 meters a second forward. That's the speed that my arm can produce, 20 meters a second. So relative to me, that rock is gonna go 20 meters a second. That's not what you guys are gonna see though. That's not what you are going to see, because I threw it off the front of a moving train. Before I even threw the rock was already going 50 meters a second, just like the train was, because it's on the train, okay? So from your point of view, if I threw it with 20 meters a second off the front of a moving vehicle that was already going 50 meters a second, how fast would you guys go or see it? How fast would you guys see it move? Yeah, 70. Because the rock was already going 50 and I gave it an extra push, it's going to look like it's going 70 now. So the speed of the train plus the speed of my throw is what you guys would see, okay? And so it seems like we're disagreeing on the speed. I would say that rock went 20, and you would say the rock went 70. But we can explain that with a consistent set of rules, because the discrepancy comes from the fact that I was moving. I saw something different because I was moving, okay? Now, one last thing I got to say about this example. Check this out. If I threw it at 20 meters a second off of this moving vehicle, after 1 second, I would say it went 20 meters forward because I saw it going 20 meters a second, okay? How far forward would you guys say it went if you saw it going 70 meters a second? After 1 second, how far did the rock go from your point of view? 70. So it seems like we just had a disagreement on something, okay? Check this out. Let me get rid of this for a second. So it seems like I said, okay, here's the train, right? That's the train. I said that the rock was 20 meters in front of the train, and you guys said that the rock went 70 meters forward instead. So it seems like we're disagreeing over where the rock ended up, but we're not, because here's the thing. I wouldn't be able to see that the train was moving because it's attached to my feet. The train was going 50 meters a second, so after 1 second, how many meters would the train have gone forward? How many meters would the train have gone forward in 1 second if it was going 50 meters a second? And we're almost done with the math, by the way. Yeah, the train would have started, back here, and the train would go forward 50. Right? And so, check this out. If the train went forward 50 and the rock went forward 70, how much more did the rock go than the train? How much farther forward is the rock than the train after the rock hits the ground? Still 20, because if this is 70 and the train went 50, this would be the difference between them. So that's still, so in other words, we would both agree, even though we saw a different speed happening, we would both agree that the rock landed 20 meters in front of the train. It's just a different point of view. So whenever we're talking about relativity, when we're talking about relative to this or relative to this, what we're really talking about is from different points of view. Sometimes you see different things, but what I said back here by saying that the laws of physics must always be the same, what that means is that even if we see slightly different situations or even crazily different situations, we need to be able to reconcile that and have reality make sense, okay?